So today, in this video, we're going to be covering chapter 3.5.2, which is factoring trinomials by trial and error. Now, I'm going to go over the method that we learned in class, but I'm also going to give some of the methods that I've learned in previous 10-15 class and 10-10 classes that seem to be good. However, if you are not interested in that, that's fine. I'll do the other methods near the end. I just want to give you guys options. Some make more sense to people than others, and it really just depends on who you are. For this, there's a crucial part that it wants us to know, and that is we need to find two numbers whose product is 7 and whose sum is 8, and not those specific numbers. But the reason why it's going to start with this, we know that the product is 7, so something times something is equal to 7. And we know that the numbers that equal to 7, that times to 7, will also add to 8. Now you could set up a system of equations. It's actually going to lead to the same problem though, which is the fact that you're going to need to just brute force it basically. So we know that the factors of 7 are 1 and 7. Luckily it keeps things easy for us. And also -1 and -7. Luckily, we know that the sum is positive, so if we add the 1 and the 7 together, that will give us positive 8. Now, for the answer, it's going to be 1, 7. I believe it wants it separated by a comma. I don't remember. It might just be 1 times 7. But I think it's a comma. And yeah, so this is an interesting but also an important concept for trial and error, for the AC method, for the method that I'll be showing near the end of the video. This is an important concept that you'll need to know. Now, we'll get into the factoring the expression. With trial and error, we want to basically set up two different parentheses. And typically for trial and error, it will typically have a 1x squared. It can work with other factors, other coefficients in the front. It's just more convenient this way. But basically we're saying, okay, what can we times to get x squared? So we can times an x and an x together to get x squared. What can we times to, and then you want to say, well, briefly, I guess I forgot to mention this. The standard form of a polynomial, a trinomial, is ax squared plus bx plus c. And we basically want to say, okay, what is a times c? And that's going to be 1 times -20. And we're only caring about the coefficients. So -20 is our answer for that. And this is where we want to find the factors. What can multiply to -20 but adds to 1? And we want to say adds to the b. So it's like a, c, and then we'll call this k. We want x and y, and not necessarily those x. We want them to multiply to k, but to add to b. Yeah, it's kind of hard to express in these. But we have -20. The factors for that, I like to start with like ones that are going to be easier to deal with. So we have 5 and 4, like the smaller ones I like to start with. So 5 and 4, I know that if I do -4, 5 minus 4 is equal to 1. And so this is our factor. They multiply positive 5 and -4 times up to 20, -20 I mean, and they add up to positive 1. So we'll have plus 5 and -4. What can I multiply this to get it? So we have x and x, and then we have -12, because 1 times -12 is -12. We have a 3 and a 4. We have, and I usually add the negatives when I need to. And then we have a 2 and a 6. 2 and a 6 seem like they're going to be our lucky winners, and we want it to be positive 4. So we'll slap a negative onto the 2, because -2 times positive 6 equals -12, but adds up to positive 4. So we'll have x minus 2 and x plus 6. Then we can factor this one, which is, so we have, this one is a little more tricky because there's no b term in the middle. We'll get more into this in chapter 3.5.4. But for now, we're just going to keep doing trial by error. We know that this times this is going to give us y and then we close parentheses there, y times y, and then what can we get? Something times something that will give us negative 64 and add it to 0. I have a feeling it's going to be 8, because 8 times 8 fell on the floor, pick it up, and it's 64. So 8, positive 8 times negative 8, these will add up to 0 and multiply to negative 64. So we do y plus 8 and y minus 8. And then y squared plus 11y plus 28. We're going to do 28. We have our y squared still. And then this can be, we want 11, so 4 and 7. And I think those are going to be our lucky numbers, yeah, 11. So positive 7, positive 4. Now, I was not enthusiastic about that because I actually don't like that method at all. That's not my favorite method to do things. There are two main methods that I really appreciate that I learned in a previous 1010 class. And it's called Hippo Butts. And there's a whole song for them. I'm going to be honest, I didn't make the song. I don't remember the song. It's something like Hippo Butts, number times the number is what times what, or something like that. I don't remember. It's just a funny little rhyme. And the way to do that is let's clear these and let's pick up a new example. Well, not a new example. For these, we still are going to do the a times c. So let me remind you that our standard form is ax squared plus bx plus c. We're still doing a times c, which is 1 times negative 20. So negative 20. And then a number is what times what or whatever. I don't know. I'm sorry. I don't remember the song. But it goes down to, we want probably the 5 and the 4 one still. We know what the factors are because we did them earlier. And we want a negative 20. And the hippo butt way, the reason why she calls it hippo butts, she was an old professor of mine. She's actually my boss now. But the reason why she calls it hippo butts is because that kind of like looks like a hippo butt, right? Yeah. I don't know how to draw hippos, but yeah. Anyway, so it's like hippo butts. So you take your 5 and your negative 4, and you say, okay, I have an x here, plus 5, and an x here, minus 4. You always keep the x in the front, and hippo butts only works if the coefficient is 1. However, there's another method that we'll probably get more into when we're talking about the AC method, but briefly, let me come up with some examples. Okay, I have some examples now. Let's continue with hippo butts for a minute. So we have our a times c, which is going to be negative 30. A number times a number is what times what, and then we can break this down into factors that we think will times to negative 30 and add to positive 13. So I'm guessing 10 and 3. And we want it to be positive 13. Oh, hold on. This makes things interesting. That actually is probably not going to be it because that's a positive 13. And we'd have to do positive. Yeah, I'm actually going to make this a positive 30 just for the sake of the example. So we're going to set up our hippo butts. Here's our butt cheek number 1 plus 10. And then butt cheek number 2 is x plus 3. And that would be your factored form. Here's the 2x. Oh, that's not hippo butts. Actually, it is hippo butts. The first thing that we want to do for when we're factoring any trinomial, and the case goes for all of these, we assume that we don't need to factor anything because it's just a 1x squared in the beginning. But for any of these trinomials, first you want to see if there's any GCF you can take out. And in this case, there is. You can take out a 2. So you leave with x squared plus 10x plus 16. No, yeah, 16. That took me longer than I wanted it to. And what you'll do is now we can see that this is a 1x squared. This is something that we can do hippo butts for. So we set up the hippo butts. Don't forget the 2 here though. X minus x something, and then x something, and 16. So we start with 16. 16 is 4 and 4, or 2 and 8. 2 and 8 is our lucky number here, so we'll do plus 2 plus 8. It's okay if you're not as fast as I am. You'll get used to it the more examples you do. So here's 49. 49, I'm assuming 7 is going to be in here somehow. 7 and 7. 7 plus 7 equals 14. 7 times 7 equals 49. So we'll set up the hippo butts. X plus 7. X plus 7. That's our answer. Well, I didn't need to circle the whole thing. Yeah. Easy. So here's A times C, which is 2. And then that can be 2 and 1. Those are the only factors for that. And so we have an X plus 2 and an X plus 1. Okay, easy. I prefer hippo butts. It's more fun. It feels like you have to do less thinking, which is what I like doing that. I like doing no thinking. I like not thinking. I don't like thinking. I do like thinking, but I like doing not that. Anyway, so now another method that is not hippo butts, not trial and error, and not AC is sort of like very similar to hippo butts. We'll take the AC, and again, I'd like to remind you that this is just extra stuff that I'm including, and if you don't care about this, it's totally fine. Just do whatever you learn, whatever works best for you. I'm just giving different methods. I don't want to confuse you. So we can take A times C, which is going to be 30 again, and we have 10 and 3, and this time we take our 10 and our 3 and we divide by our A. And we know that these are both positive. We want to keep these positives on the top, these positives or the negatives, whether it's a positive or a negative. We want to keep it on the top. And then we say, okay, this bottom one is our X part. These bottom ones are our X part. So first we'll have this. We'll set up our hippo butts like usual. This bottom is our X part, so we have a 1X here. And then we put this plus 10, this plus something right there. And you don't need a 1 in front of the X. And then you take this minus 3, we have our X minus 3, and do that. It's useful in cases like here, where it's not 1X. And also you need to reduce these first. So, for example, we'll take A times C, which is 8. This can be factored down to 8 and 1. That will give us negative 8 and negative 1 multiplied to positive 8. Negative 8 minus 1 is equal to negative 9. So we will have something. We don't have a normal X here, though. It's not going to work with a normal X. We know that because our coefficient is not 1. But what we can do is we can take our A, which is 8, and this can be reduced down to 1 over 8. So this is reduced down to negative 1 over 1. Sorry, not 1 over 8. So now we take this 1x, because that's on the bottom. We care about what the bottom is for our x. And then we have this minus 1. I remember it because it's like minus 1 usually comes after. And then we have this 8 here, which is going to be our x, so 8x. And then we have this minus 1 still. And that would be your answer for that. I personally prefer the AC method over that, but it's also a useful one. We will learn about the AC method in the next video. Here's another one where this applies. 5 times 6. Also, there's no greatest common factor in this one. 5 times 6 is equal to 30. 30 can be reduced down to 3 and 10, 5 and 6. And that's going to be our winner chicken dinner. So we'll bring over our A term, which is, and they're both going to be positive, by the way. Bring over our A term. This is going to reduce down to 1 over 1, positive 1 over 1. And we'll have an x plus 1, and we'll have a 5x plus 6. And that will be your answer for that. We'll go over the AC method in the next video. If you have any questions, please let me know. Yeah, have a good one.